Let's take a look at the PVT worksheet. Recall that PVT worksheet is still part of your thermal energy chapter, which is chapter 2 for IGCSE students and chapter 4 from 4 for SPM students. Okay, remember in this, there are three laws. The three laws are Boyle's law, okay, Boyle's law, Charles' law, and pressure law. For those of you taking IGCSE, you only need to be concerned about Boyle's law. For those of you taking SPM, you will probably need to learn all three of them. Let's take a look at an example of a Boyle's law question. Question 4 here. Boyle's law. Okay, remember Boyle's law equation is Boyle's law states that as the pressure increases, the volume of an object decreases. Okay, and vice versa, as the pressure decreases, the volume increases as long as they are at constant temperature. So recall Boyle's law's formula states that P1 V1 equals to P2 V2. The pressure times the volume in the initial stage equals to the pressure at the second stage times the volume at the second stage. Okay, just remember this relationship. Okay, this is Boyle's law equation. Okay, let's take a look at this question here. So this question, initially the cup is air. It's sitting on top of the sea. Okay, the figure shows a beaker inverted and placed on the water surface to trap some air in it. The beaker is then pushed vertically into the water until the length of air trapped is L half centimeter. All right, what it means is that the volume of the beaker is now half. All right, after you push the water in. Calculate the depth of the beaker in the water. All right, assume atmospheric pressure is 10 meters of water. Okay, recall when you do this, when you write atmosphere, you can actually write down not just in pascals and Newton per meter squared. You can also write pressure in terms of the barometer equation. Remember that? It's so in this case it's you can write it in millimeter Hg, or in this case meter H2O. So in this case water is actually 10 meters H2O. Okay, so let's use Boyle's law equation here. So P1 V1 equals to P2 V2. Initially, when the water is resting on top of the surface, the initial stage, right, the pressure was at 10 meters of water. Atmospheric pressure is 10 meters. Okay, you're above sea level, so it's just normal atmospheric pressure. So P1 is 10. Okay, and V1, okay, what is V1 going to be? V1 is just L. Okay, and P2 is actually what we're trying to find. Okay, because yeah, P2 will be given, since 10 is in meters, P2 will be in meters as well. So some of you might be wondering, the question doesn't want to find the pressure, it wants to calculate the depth of the beaker. Trust me, you'll get the depth, right, once you find the pressure. Alright, so V2, what is V2? V2 is L over 2. Okay, so if I were to rearrange this whole equation, P2 equals to 10L divided by L over 2. Okay, so what do we get? We will get 20 meters. Alright, we will get P2 as 20 meters. Okay, but you need to recall the initial pressure of air itself is 10 meters. Okay, so so the height of the pressure is 20 meters because we are adding the pressure from atmosphere plus the depth of the water. So if we just want how deep the water went, all you need to do is depth equals to 20 minus 10, which will give you 10 meters. Okay, so this H here is equals to 10 meters. Let's take a look at another Boyle's law question. Alright, this time the next question, question 5. Okay, again, question 5 just says the volume of air bubble at a depth of H meter from the lake. Let's draw it at the side here. Oops. H from the lake is 1.2 centimeter cube. What is the depth of the bubble if its volume is 1.5 centimeter cube? So based on the relationship, the inverse relationship of pressure and volume, has the bubble gone up or down? Obviously, it has gone up because the volume is now bigger, so the pressure is lesser now. So initially it's 1.2 centimeter cube, now it's 1.5 centimeter cube. All right. What is the depth of the air if the bubble is at the surface of the sea? Um, Sorry, it should be here. Of this of 1.5 cent at the surface of the sea, and the atmospheric pressure is 10 meter of water. Okay, 10 meters H2O. So just air itself is pushing on the sea at 10 meter H2O. Okay, so again, just write out the equation. P1 equals V1, P times V1 equals to P2 V2. Okay, so the initial pressure, which is here, we don't know. We don't know how deep it was, but initial volume is 1.2 centimeter cube, and the pressure on top here at the surface is just 10 meters. All right, 10. Remember, as I said in the previous question, you can write pressure in meters H2O or pascals, or it's the same. You can convert one to the other. It's not the same thing, but you can convert them. All right, but in this case, I'm just going to leave it as 10 meters. All right, V2 is 1.5, 1.5, sorry for the bad handwriting, 1.5 centimeter cube. Okay, again, just plug into your calculator. 10 times 1.5, all right, divided by 1.2. P1 equals to 12.5 meter H2O. All right, 12.5 meter H2O. 10 times 1.5 divided by 1.2 will give you 12 meter H2O. But again, this is the pressure that this bubble experiences here. But again, as I said in the previous question, you need to break this down. This pressure here is not purely just from the depth of the water. This pressure here is from water and also from air. Okay, what is the pressure from air? Air is 10 meter H2O. So again, the question wants you to find what is the depth. Okay, the depth H equals to, you need to take that into account, 12.5 meters minus the initial 10 meters from the air. So the water is only at 2.5 meters deep. Okay, so that's how you do a Boyle's law question.